So what exactly is a model? A model is simply an approximation of the relationship between two or more variables. Typically with a model, we have one or more input variables, which we call x, and we have one or more output variables of our model, which we generally call y. The model simply approximates the relationship between x and y in the form of y as a function of x, plus an error term in recognition that we generally can never create a perfect model which can fully predict the values of y without error, so we always add an additional error term to recognize that. Let's take an example of a model. Suppose we've collected a bunch of data on car engines, and we'd like to try to approximate the fuel efficiency of a car in miles per gallon from data that we've collected on the horsepower of the car's engine. You can see on the screen a simple plot where we've plotted horsepower on the horizontal axis and miles per gallon on the vertical axis. In this case, horsepower is serving as the input variable to our model, and the variable we're trying to predict, miles per gallon, is our output variable. We can create a model where miles per gallon is a function of horsepower plus some error term. As you can see on the screen, the model can roughly approximate miles per gallon given information on horsepower, but it's not able to perfectly capture the randomness of the data that we have on miles per gallon, and therefore it's important to always keep in mind that you'll always have some small amount of error in your model. Let's now go back to the example we were using previously, where we'd like to create a model to predict the sale price of homes for sale. In this example, the characteristics of homes for sale, such as the school district, the square footage of the home, the number of bedrooms, all of the attributes of each home would be the x values, what we call the features of our model. We have a number of historical observations of these features, which are represented by data we've collected on past homes which have been for sale. Likewise, for each of those observations, we also have our y value, which is the actual sale price of that home. We can use these historical observations of our input data and these historical y values or target values to then create a model which can approximate the relationship between the input data represented by our features and the output targets. In order to create a model, there's four things we need to define. The first is the set of features to use, or the attributes of our data, which we'd like to use as inputs to our model. The second thing we need to define is our choice of algorithm. In machine learning, there are a variety of different algorithms we can choose, and the algorithm acts as a general form or a template for the model that we're creating to define the rough shape and structure of the model. Each algorithm also has a set of hyperparameter values that we then need to define. You can think of hyperparameter values as knobs that we can turn on our algorithm to make our algorithm more simple or more complex to best fit our problem. And the fourth thing we need to define is a choice of loss function which we're seeking to optimize. And this is how we train our model. A loss function is a way to quantify the error in our model. And as we build and train our model, we seek to minimize the error. Thus, when we define the loss function, our job is to minimize the loss function or minimize the amount of error and to adjust the values of our model to result in that minimum of the loss function. When we train our model, we use historical data, generally on the inputs as well as the outputs. Our algorithm and our hyperparameters provide an overall form or structure for our model. And as we train our model using that historical data, we're learning values for the model which minimize our loss function or minimize the amount of error in the end model that we create.